All right. So we are going to learn more methods to evaluate integral. So we are going to focus on the antiderivative question. How do we find the antiderivative? If it's sum of power functions, we know how to do it, right? We begin with the whole problem. Then later on, we are going to have to solve some other problem, like a square of x times x plus 1 dx, right? So this is indefinite integral, right? We want to evaluate this indefinite integral. That means we're going to find the antiderivative of this function, right? Since this is a special function, we can express the sum of two power functions. Then you just evaluate, find the antiderivative for each of them, okay? And using the formula, okay, right? Use the formula, then you get the answer, right? So this is the antiderivative. And plus 2 over 3, x to the 3 over 2 plus constant. Now, if I change the problem a little bit, then what you can do? Oops. Right? Problem like that. You cannot express as a product as a sum of power functions. Right? This is our it's a challenging problem, right? Okay. Now, about the integral symbol, we notice that it consists of three symbols. Like this is like a capital S. It's a stretched. Okay, this actually comes from the sum. Okay, S. So this dx is going to be the differential of x. Okay, this is a function here. So why we have to put this stuff here, especially the dx? It has a meaning here. Okay, otherwise we just integral. Now, integral symbol is okay, like this one, right? Because we're talking about integral. Why is the antiderivative involves the three things? Except besides the function, we have a stretched s and we have dx. There's a reason. Okay, it's hard to explain here, but there's a reason why I have to put dx here. Okay, now this is very important. When you express, write down the integral of some function, don't forget the dx. It's a part of the integral. Okay, it's part of the integral. And we have the fundamental theory, right? It's going to be capital prime x dx. Okay, because the indefinite integral is going to be the most general antiderivative function. So the antiderivative of prime x is just f of x, and then put the constant here. This is a formula we learned. Right, this is formula. Okay, the left-hand side just tells you the most general antiderivative of f prime x, which is f of x plus constant. So you call it f of x plus constant. So this is the theorem we used to evaluate the integrals. Okay, so for example, if it's cosine x dx, right, this is going to be sine x prime dx. That's why it's going to be sine x plus constant. Okay. So now I'm going to let u to be capital F of x. Let's understand the meaning of dx here. Okay. So du equals capital prime x dx, right? Right? So the above formula can be simply write the following. What is the f of x minus d? Just du, and this u plus constant. So this is the simplest one we see. Okay, so the integral and the differential, they are quantity, just like a natural log. Just similar to like a natural log of e to the u is just going to be u, right? Okay, so very similar to that. That canceled out, they're inverse to each other in some sense. They're inverse to each other. Okay, so the integral and the differential, they are the inverse to each other. Okay, this is a general idea. Okay, integral. So this is a simplest formula, and the u can be anything. Okay, if you use a capital Fx, then you get the above one, and this is a simplified version of the integral that canceled out. Okay, so this is it's kind of this and du, the inverse to each other. It's not du, just d. Okay, in some sense. Yeah, this symbol and that symbol are inverse to each other, just like a natural logarithm exponential function. Okay, so that cancels out, and derivative of, if you switch the order, you get a similar things. Okay, if you switch the order. Okay, but let's use this first. Okay, so we continue. Okay, now let's go back to this, right? F prime x dx equals f of x, right? So I'm going to let x to be g of t. Okay, then what happens? Well, dx is g prime t dt, right? So I put into the formula. So I get f prime g of t, g prime t dt is going to be capital F g of t plus constant. It becomes more complicated, right? Yeah. Got it? Right. Yeah, if x depends on another variable, then dx is going to be g prime t dt. So let me introduce again. Let ht be to be the composite of these two functions, right? Then h prime t is going to be f prime g of t and g prime t, right? So you're coming back to this above formula is going to be h prime t dt equals ht plus constant. Okay, yeah. Okay, so if you let s to be h of t dt, not h of t, just ht. Okay, then then ds is going to be h prime t dt, right? Okay, so the above identity becomes just ds equals s plus constant. Oops, so this is again the simplest we have. Okay, we play with those variables. We hope understand the this formulas we are mentioning here, right? Okay, don't forget. I just want to say that this is very important. The variable dx or dy, whatever you can put there, it's important. It's not. It's part of the integral. Do not drop it. when you try to evaluate integrals, yeah, keep this dx. It's part of the integral. Just like when you draw somebody's face, you have to draw the nose, you have to draw the lips, right? You cannot ignore it. Okay. All right, so let's come back to the problem. At the very beginning, I remember this is x, right? Right. I'm trying to find the entire derivative of this function. Now I'm going to change the variables. If I can change the variables, sometimes make it easier. Okay, called substitution. Change the variable. So I don't like x plus 1, so I let doesn't matter, let u to be x plus 1. Okay. The relationship between u and x is just this. So x is going to be u minus 1, right? And the du is equal to dx. At least you can get this two things, right? All right, so the integral, the above integral now becomes x u minus 1 square of u dx is du. This is better. Why? This can be expressed as a sum of power functions. Okay, so it's going to be u to the 3/2 minus u to the 1/2 du. Okay, so what is the entire derivative of the first term? You will get, what is the entire derivative of the second term? Okay, so this is the integral right now in the new variable will become this. And then let's simplify it. It's going to be 2/5 u to the 5/2 minus 2/3 u to the 3/2 plus constant. And what is u? Yeah, x plus 1. So x plus 1 to the 5/2 minus 2/3 x plus 1 3/2 plus constant. You see, you get the answer. Okay, through the change. Very and then change the problem to some problems like that you can evaluate using as a sum of power functions. Okay. Let's do one by. Now there are some problems. The answer could be quite different. If you use a substitution, it'd be a little bit easier. Like even this problem. Okay. Even this problem. Yes, it's a polynomial. You can multiply this out. You get how many terms? You have 4 terms. And each of them is a power function, x to some power. And you can evaluate the integral, no problem. But if I change 3 to 10, you still have a formula, but it's getting more and more complicated. Okay. So the best way to do is to simplify. Yeah, use the change of the variable. Okay. Now be careful, dx is not going to just u. If the relation between u and x is like this, du equals 4x dx. Okay. Right? Differentiate 2x squared plus 1, you get 4x. All right, so let's do this step by step. It's going to be u cubed, and I change x, then dx, right? That's still okay, where u is going to be 3x squared plus 1. And x times dx is this part, right? So, okay. Then, you find the entire derivative of u cubed. Okay, and then you're done. So it's 1 over 16 u to the 4th power. And what is u? 2x plus 1. 2x squared plus 1 to the 4th power. All right, then when you differentiate, you will get the same answer. Okay, so now this method is very, very good. I can do lots of problems. Even this integral, okay, can be expressed in slightly different way. So you can let t to be quarter of u to the 4th power. Okay, and then what you get, right? And then the dt equals u cubed du. So u cubed du is nothing, just dt. So integral of dt is going to be t plus 1, all right? And what is the t? T is that, okay? So you can also simplify to the simplest integral in the world. Just integral symbol and a d of some variable. Okay. Okay, let's look at this integral. For this problem, there are 2 different ways to do it. Right. The first method, it's not. It's product to function, but you don't have product rule to integrals. Okay, so it's going to be half of sine 2x dx. Then know what? Sine 2x, right? Because sine 2x is 2 sine x cosine x. Yeah, we have the formula. Sine 2x is 2 sine x cosine x. Cosine 2x is quite different. Cosine x is cosine square x minus sine square x. And it can be 1 minus 2 sine square x is 2 cosine square x minus 1. Okay. So those are the formulas you have to know. Okay. From pre-calculus 2, right? Math 154, right? Okay, how can I evaluate this integral? Well, you have to use substitution because that's 2x here, right? So you put aside, okay, so we're not bracket, right? Let u to be 2x, du equals 2 dx, okay? So we get sine u, right? What is dx? Dx is half of du, right? Yeah, half of du. So it's going to be 1/4 integral of sine u du. Then we know this. You can use another substitution if you want. It's going to be negative cosine u. We already know the form, right? But you can, yeah, it's negative 1/4 cosine u plus constant because negative cosine u differentiate to get this. Okay. So you differentiate get sine u. So it's going to be cosine u. What is u? U is 2x. So you get an answer. All right. There's another way to do substitution. I can let u to be sine x. Okay. So du is the derivative of sine x, the cosine x dx. Okay. So this integral, what is u? U is a sine x is u. Cosine x times dx, it is here, just du. Okay. So very simple now. So antiderivative of this function is half of u squared plus constant. And then that is going to be, u is going to be sine x. And you compare this to, why they're different? Right? It's a different method. Why they're different? They're same. Essentially the same. The constant could be different. Okay? The constant could be different. Maybe I put a primer here. Okay? Then within the same problem, we use a different constant. And they're the same, essentially, because cosine 2x can be expressed as 1 minus sine, square x. It is 1 minus 2 sine square x. So this one is 1 minus 2 sine square x plus c. Okay? So then you get positive 1/2 sine square x plus c minus 1/4. So this is another constant. Okay? So that's why it's the same. So when you look at the answer key I posted, then don't be scared, oh, I get different answers. It does not mean you get different, that's wrong, it's still correct. Okay. All you have to do is just check when you differentiate whether you get the same answer. Especially for trigonometric functions, they are related. Okay. Okay. This problem was on the previous one of the previous final exams. Okay, we don't have so many problems to choose. Maybe to you, maybe just too many. You cannot memorize all these problems. But very limited problems we can choose when we make the final exam. Okay, so already have the final exam made up. Okay, we're almost done. We revise it, and we're going to print out all the copies. Right, for this one, sine square x divided by square x. Right? When you see a problem like that, the first thing you have to try is, okay, I don't like the square x inside sine, so I'm going to use substitution. Maybe I can simplify, maybe not, okay? So you just substitute on the one side, so you're not going to break the procedure here, okay? Solution step procedure, okay? So du, this is a very well known, so you should know immediately it's going to be 1 over square 2 times square x dx, right? Okay. So what do we get? Sine u. And we also have an x dx and dx over square 2 x square x. And you look at this one, right? And you put it here. So you will get sine u and the 2 du, okay? And then it's a negative 2 cosine u plus constant. Because integral of sine would be negative cosine. And it's done. So it's negative 2 cosine square x plus constant. Okay. So I'm going to ask you to evaluate the integral of the following. Cosine 1 over x, and check. Please find the antiderivative of this function. Usually, you will introduce a variable for the quantity inside some function, like sine, okay, cosine. So when you see cosine 1 of x, so it's a very natural idea to you let u to be 1 of x. Okay, then you du equals negative 1 over x squared dx. Okay, and that's what we want, right? Dx over x squared. So it's going to be integral cosine u, and dx over x squared be negative du, right? Right. So the entire derivative cosine is going to be sine, so it's negative sine u plus constant. Sine u is 1 over x plus constant. So that's it. Right. So after practice enough problems, we're going to focus on the indefinite integral. Okay. I want to evaluate the integral from 0 to 3 square root of x plus 1 dx. Okay. So how do you do that? Well, I just need the antiderivative function, right? You begin with this. So you let u to be x plus 1. And then du equals dx. So that's going to be square root u du, right? Because dx equals du. So the antiderivative of this, according to the formula, okay? So it's going to be 2 over 3 u to the 3 over 2 plus constant. Okay, and what is u, right? U is going to be 2x plus 1 to the 3 over 2 plus constant. Then, right? So you find the antiderivative, then the integral is going to be 2 over 3 x plus 1 to the 3 over 2 difference at the two end point. So we will get 4 to the 3 over 2 minus 1 to the 3 over 2, because when x equals 0, it's 1. And, right, then you simplify it. I think a 3 over 2 should be taken out. Now, what is this? 8 minus 1, okay? It's going to be 7, 14 over 3 is answer. I can also try to use a different way to solve the problem. I don't want to just leave it longer, than solution. So we go back to this, right? What I'm trying to do is I'm still use the same substitution, but I'm not going to go back to x variable. Once it's changed, just look forward. I'm not going to change it back to. Okay, we still can do this. Okay, so the idea is elect u to be x plus 1. But what you have to figure out is when x equals 0, what is u? U is 1. When x equals 3, u is going to be 4. Okay, So when x variable changes from 0 to 3, the u variable changes from 1 to 4. That's all I need, okay? Everything's changed. The square u, dx is du, and then you have to change the interval. If you forget that, okay, then you will make mistakes. So we're not going to go use the indefinite integral here. Okay, so the antiderivative is going to be, right? It's going to be, actually, it's going to be 2 over, sorry, right? So the antiderivative, okay, evaluate at the 2 endpoints. Okay. So you will get 2 over 3, and use 4 to the 3 over 2 minus 1 to the 3 over 2. Okay, so you will get same result. All right, let's look at the next problem. Yeah, the next problem is to evaluate the integral from 0 to 4x. Yeah, this is the function, and here's the 4, here's 0. When x equals 4, 3 and 4 and 3 is here. Okay. Maybe like that. This is a graph. So this integral represents the area of the region and the graph. Okay. So this is going to be the area under this graph. Okay. So can you do this problem? Right? Use the substitution, right? Find the antiderivative. Now you can start with a definite integral, find the antiderivative. Then you use the antiderivative to evaluate the integral. Or you can stick with the definite integral. You change the variable. If you don't want to go back to the original variable, you just use a new interval for the new variable. Everything okay. So the integral, definite integral, all the things that connected. Okay, if you change one, you have to change the rest of that. Okay, you cannot, leave this. It has a meaning here. 0, 4 means the variable length from 0 to 4. Okay, now you change the new variable. The interval must be changed. Okay, yeah. So this is the function is there, right? Yeah, this is like some kind of device you design, all the parts that play separate rules. Okay, you cannot forget the other part. Change one part. I forgot. When I was in high school, I'm very good about the circle. And then totally forgot. Okay, so yeah, do your best. If you can quickly learn that and do it in the classroom, then you spend less time until you get home. We are not in big hurry. Trying to slow down. Yeah, to the end, maybe a little bit complicated to find the entire derivative, but at least you should get some idea correct, like substitution. All right, let's try. So the first thing, I'm going to change the variable, and I'm not going to go back to the original variable. So you let u to be 1 plus 2x. That's my new variable. It's called a transformation of the variable. Okay, the integral you're going to get will be quite different from, the value may be the same value. I will explain to you this later. So du equals 2 dx. Okay, right? And when x changes from, what happens? So the software is, there's some debuggers. It's not very stable. I didn't touch anything, just disappeared the integral symbol. So it's possible when you print out the lecture notes, you're saying something's missing. Okay. So when x is 0, right? U is going to be 1. When x runs to 4, u is going to be 9. Okay, good. So that's the u variable. And so 1 to 9. Okay. What is this? And the dx is half of du. How about x? Well, I can replace x by u minus 1 divided by 2, right? That's cool. So eventually you get 1/4 and du, but this is a good because there's a single power function in the denominator. So you can use a traditional method to evaluate the integral, right? Okay. So you know how to find the entire derivative of this. But the geometric meaning of this integral, let's look at this integral. This integral right now, this is a u variable, this is a v variable, for example. V is going to be, so v is going to be u minus 1 square of u. Okay, you start from 1 and to 9. The graph when u equals 1, I think it's a 0, start from 0 again. When u equals 9, it's going to be 9 minus 1 over square root of 9 divided by 4. So it's 8, 4, 3, 2 over 3, somewhere here. So this is a graph like that. Okay. I may not draw a perfect graph, but this is going to be 9, 2/3. Okay, that one is a 4/3. So those two regions look a little bit similar, but they're quite different. Okay, so there's actually transformation from one word to another word here. Okay, they have the same areas, those two regions. Okay, but they're already deformed in some direction. Okay, this is called the kind of transformation. Change the variable means you change the world. You know, in physics, when you change a coordinate system to another coordinate system, change the x, y coordinate system to the polar coordinate system, for example, right? And then the images look quite different. Okay. All right, so we get we find the antiderivative of the first one is 2/3 u to the 3/2. The antiderivative second one, I think, is going to be 2 u to the 1/2 when you differentiate. Yes, it's 1 from 1 to 9. Okay, so let's evaluate. Okay, that's the first term. The second term is just 1 and 1. Okay, now after simplified, I eventually get 10/3 if I'm okay. But if that's on the test, you know, if you don't have time, you look at the watch, you know, don't have much time, just stop here. Don't do the computation. Move to the next problem. Only when you have a time coming back, because maximum, you know, you only lose 1 point out of 10. But there are some other problems, 10 points you can easily get. Okay, so it's very important to figure out the strategy to do something. Okay, you know, yeah, just like I remember that lots of kids went to the park to, you know, eat, right? They pick up the eggs. I just observed that some kids are very smart. They can get lots of, some kids and now that's and then learning around it still get very few. So you have to learn the strategy. The strategy is very important because they hold the line when they lift, then all the kids go inside, right? You remember, maybe you did that before, you know, when you were a child. Yeah, the strategy is important. Save your time and maximize the return. Okay. Yeah, I still remember that one child I saw him. He ran far away all the way to the end. And then he probably is the only person he picked up here because lots of other kids just pick up the whatever they see. Then they are crushed. There's so many kids in the same area. So sometimes when you reach that one already about another child, right? Then you have to move to another one. Okay, then I saw it already gone. Then after a while, you find it's still empty basket. You know, the strategy, yeah, it's important. So here it's the same thing. When you do the problem, you stop again. You know this computation will be complicated. It takes 3 minutes. Maybe you can make mistakes. So you move on to the next one first. Okay, come back. Yeah. Okay. So you will see that some integrals will involve radicals. It's not the power. Yeah. It's exponential. The power function. And yes, that can eventually can simplify, but takes time. All right, so the next one. This is the number 51. That's going to be cube, the square. Okay, sorry, I need to change. Yeah. All right, so let's do this problem. Now clearly the function is defined because x is between 0 and 1. Square of x is defined, right? And how can we evaluate this integral? The answer you're going to get, let's do some estimate of the integral, definite integral. Look at, right? Estimate first. So when x equals 0, and this is a 1. But when x equals 1, you get very small number. Goes like that, okay? So think about that. The number you're going to get is definitely smaller than 1, right? Even smaller than 1. I'm not sure, maybe 1/2, almost. Okay? So look at this region, right? It's inside the square. Okay, it's a square, okay? The reason I wanted to look at the picture first is because maybe because of computation mistakes, you get some numbers larger than 1. Then you should be able to go back to look at, to check yes, check some steps to see if we all the computations. Okay. So what substitution going to use? Okay. 1 plus square of x is in the denominator. All right. So this, you have to make choice. Let u to be square of x or 1 plus square of x. I think if you let u to be 1 square of x only, then you still have to deal with 1 plus u to the 4th power in the denominator, right? It's not good. So it's better to just consider both 1 plus square of u. So one single power function in the denominator. Okay. So now du equals 2 square x dx. Okay. In other words, dx equals 2 square x du, right? Now what is the square of x? It's twice of u minus 1 du. Okay. That's good. Okay. So we can replace everything. Okay. Don't forget this is u to the 4th power. And dx is 2u minus 1 du. Now, what is the interval for the u variable? When x equals 0, u is 1. When x equals 1, u is 2. Good. Okay. Then, we should express it as power function, the sum of power function. Then you find the antiderivative of this function. It's going to be negative 3 plus 1 u to the negative 3 plus 1, right? All right. So let's simplify a little bit. It's negative 1/2 u to the negative 2, negative 1/3. So it's plus 1/3. Okay. Let's simplify. Right. Minus. All right. We needed to spend 1 minute to simplify this. Let's try our best. I hope there's no mistakes. Okay. This is last. We can number because it's almost the end of the examples, right? Suppose. So you have to be careful to do this problem. It's 1/8. But there is a 2 canceled out. I think I should cancel 2 here. Okay, so let's do the cancellation first. Okay. And then I got negative 1 plus 2/3. Okay. So I think I can take a negative 2 out. It's 1 minus 1/3, right? So here, if you take a negative sign out, it's 1 minus 2/3. Be careful, right? So not too bad. And here's 2/3. That's 1/3, right? 2/3 is cancelled out. The 1 is going to be 2 to the negative 1. So it's 1/6. Okay. And this is a number smaller than 1. And you look at the picture, I already know that it's going to be smaller than 1. So this is the answer. Okay. Yes. Screw that. All right. So I wanted to do this one. X plus 5 is negative 1 to 4. And this is going to be, square. So it's going to be 3/2 dx. Okay, please do this part. Okay, so let's do this problem. We need to just use a substitution, right? X plus 5, then du equals dx, that's simple. So when x equals -1, u is going to be 4, right? When x equals 4, u equals 9. So that's a new interval for the new variable. So the integral becomes from 4 to 9, u to the 3/2, and the du. Okay? Then you just find the antiderivative of this function. And this is the antiderivative, right? Then you evaluate at the two endpoints. So let's simplify it. 2/5. Okay, then you get 2/5, 9. Okay, questions, can you simplify a little bit of this? Yes, because 9, the square of 9 is going to be 3. So 3 to the 5th, 2 to the 5th. Okay, it's pretty large number. Okay, 3 to the 5th is 3 square times 3 square times 3, 81 times 3, right? 243. That's what I do, right? And the 2 to the 5th, I'll do the same way, right? 16 times 2 is 32. 43 minus 32 is going to be 211. Okay, and then you can simply write the 422 divided by 5. That is the way I do this problem. Okay. So the substitution is used everywhere. Okay, and they're very useful. Okay, for example, remember we're trying to find the up semicircle was radius 1, right? Was radius r, the area, right? Now probably I can help you to do this problem. Okay, so but there's different types of substitutions. So the area of the semicircle, right? If you can get that, you can get the area of the whole circle, double it. So it's going to be integral from -r to the positive r, and r squared minus s squared dx. Right? So that gives you the area of the semicircle. Of course, the students in the elementary school, 5th grade students are already told this is going to be pi r squared divided by 2, maybe, right? But they don't know how to prove it. Okay. But some good students can prove the area formula is going to be half of the base times height. But that's not the definition. Definition is only for the rectangle. The area is going to be length times the width. And you use that to derive the formula. So question, how to get the area formula for the circle? Now use the calculus to solve the problem. Okay, so this is a giant step for mankind. I introduce the calculus. Okay. So how can I do that? Well, you may guess, oh, we should try to use substitution r squared minus y squared, let it to be u, right? It's inside radical, but that does not work. Okay. That does not work. So but we can freely choose a variable. So you can even let x to be r sine t. How about like that? Okay. That's fine, right? So this is under substitution. So t should be between could be between, because this is a t, this is a x, right? This is a t. T is between 0 and pi. Okay, right? So what is dx? Dx is r cosine t dt. Okay, fine. Right? So I assume that you know all the formula for sine cosines. So now the integral here is r squared and r squared sine squared t, and that is r cosine t dt. Okay. And the t is between 0 and pi. That's it. Then you simplify it. R squared can get out, but 1 minus sine squared is going to be cosine squared t, right? That's okay. Wait a minute. T is not going to be, hold on. T, x is cosine, no, x is cosine t, sorry, it's not cosine. I needed to, if you use a picture here, so not sine, okay, cosine. Yeah, otherwise I'm going to have a trouble here. Okay, x is a cosine t, right? Because look at this, polar coordinates, for example, if you use, right? X is cosine t. So t is between 0 and pi. When t equals 0, you get r, right? Yeah. So the derivative of dx is negative sine t. Okay. So this will be cosine squared t negative sine t. Okay. So this will be negative. And here 1 minus cosine squared be sine squared. Okay, now it's easy to do. It's r squared. And cosine t is always positive for t between 0 and pi. So it's cosine t. No, it's a sine t. So we have a sine t, negative sine squared t dt. Now this is negative. I have to be careful. My sine. Okay, why that's okay. Be careful. The interval. Okay, when t equals, when x is negative, when t equals pi, x is going to be negative, right? When t equals 0, x equals r. Okay. So my interval also should be from pi to 0, not from 0 to pi. Okay. Otherwise, it's harder to explain the negative sign here. So now, if you change the order, okay. So what is the integral of sine squared t? You cannot evaluate this. But remember, sine squared t is going to be 1 minus cosine 2t. Okay. So that is going to be so there will be two terms. Okay, the entire derivative, the first term will be 1/2 t. The second term, be careful, 1/2. The entire derivative sine cosine 2t will be sine 2t divided by 2. and we did that before, so I just write down the answer here. And then you put the pi for t, and the answer will just pi half pi r squared. Okay, so that's yeah. This is slightly beyond the section covered, but it's a substitution. So we learn this substitution. We can learn this substitution here to find the area of the semicircle with radius r. Okay, so the question is how to find the how to evaluate the integral of sine squared t, right? Sine squared t, the integral of sine squared t, you have to use the double angle, half angle formula, okay, to evaluate. Okay, so it's good exercise how to find the integral of sine squared t. Okay, I stop here. Yeah, this last problem, if you feel difficult, it's okay. We don't need to pay too much attention to this. But I just show you, yes, we are able to use substitution to evaluate this integral comes from the area of the semicircle. Okay, that substitution, you can let x to be some function, or you let inside the radical being one single function. There are many ways to do substitutions.